So with all of these examples of things in place, we'd just say that the internal parts, or as we may refer to them as data attributes, which maintain the state of each device that we discussed, should be made private. And that is kind of natural because, ultimately, we want to control internal structure of our components. And if we make those components public, it's going to be much harder, because if we change something, somebody who is used to already expecting it, they will be complaining and saying, "Oh, you changed all of this. You suddenly broke so many things. I'm becoming very unhappy." So the more you hide, the more flexibility you have to make changes, to make adjustments, to make to add new features, and even fix bugs. All of that is much easier if things are made private. So today's focus is going to be switching between the idea of this common interface that everybody understands but also implements. So we're going to say that anything that is not public, inside of our classes, and here's an example of Java code and UML diagram, anything that's not public is part of the class implementation. And again, I'm flipping between the class and object. Remember, in my mind, it's easier for me to talk about the actual instances of objects that really do exist, because I can do things to them. That's when I say object. When I think about the design of this object that I really don't even know how it's going to look like, maybe I'm just still thinking the entire concept, of course I'm talking about the class. Because the class, this is where I actually write everything to make it happen. I'm really trying to define it. Okay, so this is from the textbook, example from the textbook. We can examine. There's a class named Square. Okay, so I'm just trying to make it a little more visible. In Square, a kind of meaningless idea, just demonstrates the technical workings of the class. There's a private data attribute named Square value. Then there's a public get Square, and it takes integer value. And what it does is that it computes the square by multiplying value by itself, right? Value times value computes the square of a number. Now I can also see that there is a typo right here. Of course, this is uppercase square value. It doesn't match the name of the actual attribute, so I'm expecting that this will not compile. You can guess that I never compiled this example, just pasted it in, or maybe typed it in. I don't remember exactly where it originated from, but anyhow, this will not really compile. So to be able to compile it, we need to make this lowercase so that this is the variable name matches. So this is what happens. The user will instantiate an object named in Square. Perhaps we can demonstrate this real quick. So file, new project. I will say Java application. So this will be another console application. I will store this on my portable drive. We have some NetBeans projects already attempted, so I will keep it on my drive, and I will name it interface demo, just one word like that. And the only thing I'll change is this main app class. It's kind of easy to do something like that. So I will create it. NetBeans hopefully will create an empty shell for me. I will just make it so that we have more space to work with. I remove some of these comments, but still, mark the ending of my class here so I can recognize what's going on. And we said that if you expand the view of your project, you will definitely find the source packages subfolder, if you will, in this project view. And that's what corresponds to our location of our project, SRC, the source subdirectory. So here, if I look it up, there's this interface demo package declared at the top of my class, which, by the way, has to be the first statement in your Java source file if you're using packages. Likewise, when I look down here on the source, here it is. Interface demo is the subdirectory here, or subfolder, whichever terminology you use, and here's my Java file. Okay, so I just want you to be aware of it and just sort of like, get a pretty good feel for it. It's always going to be the same way. So the next thing that I'm going to do is that, since I already have this package, which is just a logical organization of my project, and it's very typical nowadays to declare a package on top of every source file, then over here I can right click and say new Java class. So notice that I'm adding a new Java class, which will be this in square idea, but I'm doing it under specifically, not under, but specifically for this package under my source tree. So that's where I'm going to say new Java class, and I'm going to steal the name of the Java class from the handout. It's called in square right here. Control C, Control V, and that's about it. That's all I need to make in terms of changes on this little wizard string. So it creates it for me, but I can quickly jump, select all of this, right? Control C again, and Control A, Control V, paste it in. And NetBeans is smart enough to tell me, oh, I really don't recognize this part. This seems to be some sort of a problem. So I will correct it by changing it to lowercase. So this is, recall that we're trying to demonstrate the idea of public interface versus implementation. So now that I've done this basic steps into, to put everything in place. Oh, one thing that's missing still, the package declaration. Since we're trying to be part of the same package and we're in that subdirectory, what I need to do, I'm actually going to paste the package declaration right at the top of my source file. So that way everybody agrees, the programmer agrees, Java compiler agrees that we're all acting as part of the same component in our application, and that's called package interface demo. So now I can minimize some of this stuff and get reorganized to new document tab group. Very nice to have it side by side, and try to do something useful. For example, what I can do here is that I can say I would like to create in square, right? So I'd like to, I'll name it calculator. Okay, so it's capable of doing some calculations. And as you know, to instantiate a new object from already existing class, I must say new. New is the operator that creates an actual instance. I have to specify that this is the type of object that I'm creating, and I'm also going to say that I am not going to by specifying the set of empty parentheses, I'm telling the new operator, I guess, and ultimately the constructor of an object, that I'm not using any specific initial parameters to configure the class. So it just gets configured by whatever, containing a chance value over there. I guess it will be 0 to begin with in Java, but in other programming languages it may contain just garbage value. And then I can say integer result. You can sense that I really like the name result variable, to name variables result in those demo programs, where I can now say calculator dot is the member access operator, and I'm going to say get square. Okay, so compute the square of 3, right? So what is the square of 3? So this is what happens. What happens is that this particular method get square is going to be invoked by this line, right? The square will be calculated. We'll take a look in a second on what's going on inside here, but it's going to execute. It's going to compute 3 times 3, right? And it's going to come back and give me the result. Now I'm free now to do whatever I want with the result. I may as well just say print it. Print line, and print something like result is, and for the sake of difference I will just print result on a separate line. Okay, something like that. The result is, and then on the next line it's going to print the result. So let's save this and run it just to test the ground if everything works. Right, so hopefully if I didn't make too many mistakes, it's just going to run. On the status bar here, it indicates that it's trying to do something, and obviously it comes back and says result is 9.